This program is made by the volunteers at Math Circle Online. Please join us to explore the wonders of math.
Today we'll be looking at the 2015 AMC 10A problem number 14. Question says that the diagram below shows the circular face of a clock with radius 20 centimeters and a circular disc with radius 10 centimeters externally tangent to the clock face at 12 o'clock. The disc has an arrow painted on it, initially pointing in the upward vertical direction. Let the disc roll clockwise around the clock face. At what point on the clock face will the disc be tangent when the arrow is next pointing in the upward vertical direction?
Okay, so we know that the radius of the arrow circle is half of the radius of the clock. So that means that the circumference is also half. The circumference of the smaller circle is also the half of the circumference of the clock. So the circumference would be 20 pi for the arrow circle and 40 pi for the clock. Now, if you do half of the circle rotation for the arrow circle, then it would be 10 pi if you travel this much around the circle. And then that would also equal to a quarter on the clock. So, and a quarter on a clock is from 12 up to 3. That's a perfect quarter. And so we can redraw this diagram to have it looking like this. So after rotating 180 degrees on the smaller circle perspective, you would get the arrow pointing to the left at 3. And since it traveled 3 units on the clock and it made a 75-degree turn, kind of like, like 75 degree out of a 360, 75% of a 360 turn, then that would mean to make it a full 360 and make it pointing back up again, then we would have to move 1 more unit down to complete it to 100%. So the answer would just be 4 o'clock.